This is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate. Please don't share personal information during the class for your own security reasons. Yeah, Shoshana, I will need to get you that on the day of, though. I don't have that made yet, okay? All right, so what I want to know is on the whiteboard, go ahead and let me know, what are you most excited about for the summer? Go ahead, get your answers up there. Tell me, what are you most excited about for the summer? Yes, I know that feeling. Awesome. I see Efren on the board, Shoshana, Andres. Get your answers up there. Make sure you're participating. Tell me, what are you excited about for the summer? Love it. There we go. I see Dorian working on the board. Jody, TJ on the board. Israel on the board. Thank you. Yes, Bradley. Arrow, Dolly on the board. Thank you. Perfect. Looking good. Yes, Ireland graduation coming up so soon. Aw, you are so nice, Efren. Looking good. Get your answers up there. I know, congratulations. That's so exciting. I'm super excited to see you at graduation, Ireland. You said you're at the Anaheim one, right? The Southern California one. Excellent. Hi, Chanel. Good to see you. Hi, Blossom. Looking good. Yes, I know. I'm so excited. You'll definitely have to come introduce yourself to me. Remember, though, if you're at graduation, you're introducing yourself to me, make sure you use your full name so that I know who you are, because I have a lot of students throughout the school year. So if you just say hello, first off, I won't know who you are. And if you only say your first name, that doesn't mean I always remember who you are, because there's no last name. Although Ireland, you have a pretty unique name, so I'll probably know who you are. Cool. I don't think so, Efren, unfortunately. I know, it's so sad. All right, let me go ahead and go over our answers here. So let's see here. There's no more school during the summer. Oh, you did? Okay. So yeah, Efren, maybe talk to somebody. I don't know who you would talk to about that, though. Excited for memories, your friends, and you are going to make Noah excellent. No school starting on your career, Shoshana. Love it. What career are you talking about? Israel, you said you are going swimming over the summer. Cool. We've got football camp. That'll be fun. Kiana, 2 jobs. What are these 2 jobs? Efren, you said you're going to be sad because you won't see me. You won't have game days. Well, I'm sure you'll have plenty of things to make up for that. Um, okay, so like landlord stuff. Gotcha, Shoshana. Tenant stuff. Cool. Um, Dolly, you said you don't have to worry about schoolwork, right? Dorian, your first summer job, learning to become a therapist. Amazing. We've got more votes for swimming from Andres Swimming Pools. Anime Expo 2019. That'll be great. Staying up late, sleeping in, graduating, Dree. Which ceremony are you going to be at, Dree? Leaving Kava, Caleb, so you're almost done. Flying to Hawaii with your family. Hawaii? Oh my gosh, I am so jealous. I want to go to Hawaii for sure at some point. I know, so sad, right, Israel? It's okay. You can always email me, let me know how life's going. Doing a dance class, Amanda? That'll be great. Arrow, doing absolutely nothing. Sounds amazing, right? Um, cool, Efred. Okay, Ireland, you said your family lives down. Oh, so that's why you switched to the LA one. That makes sense. Dorian, Anime Expo, you wish you could go. Yes. More time to work on your car. I like that, Jody. Let's see here. Summer job and going to the pool, Amanda. Cool, cool, cool. And let's see here. Did I get everyone's? I think I got everyone's. Awesome. All right, guys. Well, we're definitely going to talk more about summer as time goes on because we're getting really close, but I want us to start getting pumped. It's almost the end of the quarter, almost ready for summertime. Going with your brother and best friends, Jacob. Oh, awesome. Cool. Oh, no, Ireland. I'm so sorry to hear that. That's so sad. I'm glad you get to see her, though, at least. That's always a blessing when you at least get to see them before they go. I'm sorry to hear that, though. All right, guys, let's go ahead and open up your ticket. I do need green checks from everybody. Those links and the password are in the chat box. I've got 7 green checks so far. Thank you for those of you that are on top of that. Awesome. I see more green checks coming in. Let me know if you're having any issues with a red X, if you're having issues opening those. Oh, no, Efren. Yeah, sometimes it's not good to dwell on that stuff. Sometimes we just got to be thankful for the time that we have with people, right? Yeah, because otherwise it can definitely get really, really scary really fast for us in our heads. Yeah, so always remind yourself, be thankful for what you've got and kind of live in that moment. Dorian, you said pool's going to be nice and cold. Can't wait to do some belly flops. Well, that might be you, but I would prefer to avoid belly flops. Awesome. All right, there are only 8 days left of school. Go ahead, give me some smileys if we're excited about that. I am very happy about that. Today we do have a game day. You do actually have a second game day this week as well. We're going to have a game day on Friday after we go over our organic chemistry unit. Can we do something fun on the last day, Efren? Sure. Let's see here. On the last day, we can all go get pizza and then have pizza party virtually. How's that sound? No, it's not, Kiana. I won't. The last word, I give that to you at the end of class. Cool. All right, let's go ahead and, sorry. Tomorrow, please be aware that no pineapple. I mean, if you're picking up your own pizza, then you get to choose what's on your pizza, hopefully. Or you can choose something else if you don't want pizza. But yeah, we should plan something for the last day, so I will keep that in mind. All right, so sorry, what was I saying? Tomorrow I am proctoring another exam for state testing. So we should only have the recording tomorrow for state testing, so just keep that in mind. That's going to happen tomorrow on Wednesday, but I will be back on Thursday. Thursday we'll have our class again, and we will finish up Unit 10. Friday, again, is a review day. Go ahead, give me a smiley face, everyone, if that makes sense. Oh yeah, we can watch a movie. Maybe we can watch some Magic School Bus or something that goes over the stuff that we went over in class. I love the Magic School Bus. What? No, Efren? All right, so today is Tuesday the 4th. Oh man, Magic School Bus is great. You can see here we've only got a few days left. The last day is on Friday, and that is going to be last day is on Friday, and that is going to be the 14th. Courses are going to close at 11:59. No, we still have the final exam, Dree. So remember that on the 10th and 11th, we're going to be doing our final exam. Sorry, I'll type that up here. Final exam. Yes, Miss Frizzle. And the first day, so Monday is going to be the multiple choice portion of the exam. And Tuesday, we're going to go over the short answer portion of the exam. Okay, smiley faces, everyone, if that makes sense. So that means that the makeup days are actually the 12th through the 14th. So these will be days where there's no new assignments, and live sessions will be check-ins. So you only need to come for a couple minutes, check in with me to get your points for those days. Okay? All right, so those will be those last few days, and then Friday we can have a party or something. Cool. All right, everyone. So Unit 9, we are talking about acids and bases, right? We talked about acid and base reactions. We talked about their definitions. Oh, it's your birthday. Awesome, Caleb. Sorry, which day is that? Is it on the last day of school? And then we are going to be talking about the pH, or we talked about the pH scale, and we also talked about buffers as well. Oh, exciting. How old are you going to be, Caleb? On the 14th. So it'll be a end of year party and a birthday party for you. 17, exciting. Cool. All right. So we're going to go ahead, open up Kahoot. Remember that we are actually also reviewing Unit 8. So we're going to talk a little bit back about Unit 8 as well. I'm not going to give you work on the last day of school. You do need to, open up the game pin, When you open up Kahoot.it on your phone or your browser, you'll need to enter the game pin, and then match the pattern on the screen. Make sure you include your first name and last initial. Remember, just do your best, and if you need to, you can play in private chat as well. All right, thumbs up, everyone, if you feel good about these instructions. I'm going to get this ready. Want to make sure nobody's confused. Again, you can also open a private chat by double-clicking my name and sending me a smiley face. I've already got a bunch of people doing that, so I see Dorian and Dolly in the private chats already. You'll wear a costume. That would be fun. All right, looking good. Answers, good, good, good. All right, let me go ahead and get this started and up on the board. Looking good. I'm gonna also go ahead and pause my video. All right, here we go. All right, can everyone see my screen here? No, you would never do that. All right, good. Pin for today is 403543. Oops, sorry, that was not wrong. 435. Oh, no, that is right. Okay. And then I will read off the pattern a few times. Get your names up there. Blue, yellow, green, red. green, red, blue, yellow. Okay, no worries. I see Tony in the private chat. Yellow, blue, green, red. Again, if you need a private chat, you can let me know right now, or you can open one yourself by double-clicking my name and sending me a smiley face or a message. All right, green, blue, yellow, red. Yes, Jasmine, I can open up a private chat for you. Here you go. Okay, yep, no worries, Israel. Looking good. Blue, yellow, red, green. I'm going to rate it off about 5 more times, and then we're going to get started. Red, yellow, green, blue. Yellow, green, red, blue. Blue, red, green, yellow. Green, red, blue, yellow. One more time. And yellow, red, green, blue. And then we're going to get started. If at this point you haven't joined, go ahead, double click on my name, open a private chat so that you can play. Looking good. I'm going to go ahead and take a picture of who I've got up here. Miguel, Caleb, Matt, Jody. Awesome. Looking good. All right, let's go ahead and get started, everyone. All right, when balancing a chemical equation, the blank on the left must be equal to those on the right. Is it red molecules, blue coefficients, or yellow atoms? Think back to when we were balancing our equations. What did we want to have balanced? Think back to those letters that we were balancing on each side. Were those molecules, coefficients, or atoms that we were representing? Awesome. I see Israel, Dorian, Jasmine, Misael in the private chat. 10 seconds, everyone. Thank you, Tony. Hard already. I know, it was from a while ago since it was Unit 8. All right, this was actually the atoms. So we actually balanced the atoms on each side, right? The molecules themselves can change, right? So we have hydrogen and oxygen on one side, water on the other side. So the molecules can change, the coefficients can change, the amount of each molecule, but the atoms themselves do in total need to be the same on left and right. So let's go ahead and make sure that makes sense. Parker, Mr. Alt, Razi, TJ, and Orlando on the board. Does this make sense? All right, so we can see here, right, that once we balance these, the total amount of hydrogen atoms and oxygen atoms on each side had to be equal. But obviously their coefficients could change and the molecules could change. So red, sort of, blue, not yet, yellow, yes. So it was actually the number of H's, the number of O's had to be the same on each side. 10 seconds. Hi, Damien, good to see you. Go ahead, either join our game or join me in a private chat. 2, 1. Awesome. All right, so again, taking a look here, right, when we balanced the equation, the molecules did change, right? We started off with hydrogen molecules and oxygen molecules becoming water molecules. So that changes. That doesn't have to stay the same. And when we figured out how many of each of those we needed to make this balanced, the coefficients didn't need to stay the same either. The only thing that needs to stay the same is the total amount of atoms. So there had to be 4 hydrogen atoms in total on the left and on the right, and 2 oxygen atoms on the left and on the right. Smiley faces if that makes a little bit more sense. I had a couple people who were saying that that doesn't make sense, so I want to make sure we understand. Smiley faces, everyone, if we understand. Thank you, Orlando. Perfect. Shoshana. Noah, thank you. Good, good, good. All right, awesome. Let's keep on going here. All right, which of the following is correctly balanced? Which of the following is correctly balanced? All right, so we have our, we have this already balanced for you, right? So you can see the number of irons, oxygens, and iron oxides. Go ahead and show how would I represent that correctly with these equations. Okay, so I already balanced it for you on the board. You just need to fill in the coefficients correctly. We've got 4 irons, 3 oxygens, 2 iron oxides. Which one is correct? No worries, Dolly. Glad you're back. All right, that was a tricky one. Let's take a look at that. All right, how many irons do you see here? How many irons do you see here to balance this equation? How many iron molecules did we need? Yes, we needed 4 of them. 1, 2, 3, 4. 4 circled irons. How about how many oxygen molecules did we need? Again, just count the big circles. Count the big circles of oxygen. How many oxygens do we need? Yes, we need 3 of them. 1, 2, 3. And how many iron oxides did we need? Take a look at this last one. How many big circled iron oxides did we need? Yes, Efren. Yes, Arrow. Yeah, Damien, you can play in the private chat. Yeah, you should see 2 of them. So when we balance this out, that means that the red one is actually correct, where you can see 4 here, 4 irons, 3 oxygens, and 2 iron oxides. Smiley faces if that makes a little bit more sense. So remember, the big number in front tells you how many of those that you needed. How many of those that you needed. Yeah, Damien, you can just type the color in the private chat. Perfect. All right, Mr. Alt, Orlando, Parker, Rozzy, TJ on the board. Does this make sense? All right, so again, we count up 4 of them, and that becomes the coefficient. Count up 3 of these, becomes the coefficient. Count up 2 of these, that becomes the coefficient. Red, yes. Blue, sort of. Yellow, not yet. Go ahead, let me know if that makes sense. No worries, Andrea. Glad you are here. Yep, getting that private chat. Perfect. 10 seconds. Dorian, sorry, go into the private chat to answer so that I save all of those answers from you. Perfect. 3, 2, 1. Awesome. All right, let's keep on going here. The substance that gets dissolved in a solution is called is it red, the solute, or blue, the solvent? Which one gets dissolved? Which one is the one that gets dissolved? Think about again. What gets dissolved is what we have less of, and there was a trick for us to remember which one we have less of. Awesome. Thank you, Andrea, Dolly, Misael, Israel, Damien, I see you in the private chats. Thank you. Tony, Dorian. All right, it's actually the solute. Remember, which word is shorter, solute or solvent? Tell me in the chat box, everyone, the main chat. Which word is shorter, solute or solvent? Yes, solute is the shorter word, and therefore it's what we also have less of, and that's what gets dissolved. Smiley faces if that makes sense. So solute is shorter word, which means it's what we have less of, which means it's what gets dissolved. Kind of like sugar and water, you have less sugar than the water. Awesome. All right, Mr. Altrazi, TJ, Israel, Orlando on the board. Does this make sense? Let's take a look at this. So solute, what gets dissolved. Solvent is what does the dissolving. Remember, water we call the universal solvent because it's really good at dissolving stuff. Red, yes. Blue, sort of. Yellow, not yet. So 15 seconds. So if you can remember water is the universal solvent, that'll help you remember that a solvent is what does the dissolving because water is really good at dissolving. 10 seconds, everyone. Looking good. Thank you, Israel, Damien, Tony, Dorian, Jasmine, Andrea, Dolly in the chat box. 3, 2, 1. Awesome. All right, let's keep on moving here. Define electrolytes. Electrolytes. Are they charged ions that carry electrical current in a solution? Are they the substance that does the dissolving in a solution? Or is it the largest amount of solute that dissolves in a solvent? What are electrolytes? 15 seconds. Remember, we talked a whole bunch about why electrolytes are so important to our bodies the other day. All right, 10 seconds. Awesome. All right, so yes, electrolytes are charged ions that carry electrical current in a solution. So remember, we talked about how when salt gets dissolved, which is made up of sodium chloride, NaCl, it actually breaks apart into Na plus sodium ions and Cl minus chlorine ions, and with those ions in solution they can carry electrical current, and that allows them to carry electricity through water or through our blood or through our plasma in our bodies or through our interstitial fluid. We talked about that as well. Smiley faces, everyone, if that makes sense, right? Electrolytes, that's why you have electrolytes in those sports drinks. That's why there's salt in those sports drinks, because you carry electricity in your body. Your heart is electrical, your muscles are electrical, your brain is electrical. You need to be able to carry electricity. All right, we got Mr. Altarasi, TJ, Israel, and Orlando on the board. Does this make sense? Let's take a look at this. All right, electrolytes, ions in solution that can carry an electrical current, right? We have electrolytes in our blood, plasma, interstitial fluid, right? Which is why we have sugar and salt in our drinks. Sugar for the energy, salt for the electrolytes. Red, not yet. Blue, sort of. Yellow, yes. 10 seconds. Let's make sure this makes sense. Go, go, go. Awesome. All right, Mr. Altrazi, TJ, Israel, Orlando on the board. Metals have 1 to 3 valence electrons, so they will do what to electrons in solution? Will they gain electrons or lose electrons? Remember, which is easier if they only have 1 to 3 valence electrons? Are they going to red gain or blue lose? Metals have 1 to 3 valence electrons. What do they do with them? Red gain more or blue lose them? Which one is easier? If you've only got 1 out of your 8, which one is easier, to gain more or to lose the 1? 4, 3, 2, 1. It is actually easier to lose. Think about this. If I have one electron on my valence shell, all right, in order to fill this up, I would need to gain how many more? Tell me in the chat box. In order to get to the octet, the rule of 8, how many more would I have to gain? Right, Efren, I would have to gain 7 more. So again, it's easier to lose 1 than to have to gain 7 more. Smiley faces if that makes sense. Right? It's much easier just to lose 1 than to have to gain a bunch more. So metals will lose electrons. They will become more positive. They will become what we call cations. All right? Awesome. Mr. Alt, Razi, Israel, Arrow, TJ on the board. Does this make sense? Take a look at this. Metals only have a few valence electrons. It's much easier to get rid of them. So in solutions, metals will lose those electrons. They become positive cations, and we get colors by these positive metal cations. Red, yes. Blue, not yet. Yellow, sort of. 15 seconds. Again, it's the idea of the rich get richer and the poor get poorer when it comes to talking about ions. Awesome. Thank you, Dorian. Thank you, Dolly, Tony, Andrea. Awesome. All right, everyone. Copper 2+ ions in solution are attracted to a blank charged object, coating it in solid copper. Are these positive ions going to be attracted to a positively charged object, red, or a negatively charged object, blue? Think about when are things attracted, when they are the same or when they're opposites. 15 seconds. Remember, we coated a quarter in copper. What side of the battery was that quarter attached to? Was it attached to the positive or the negative side? Copper 2+. Yeah, this is a positive. Awesome. Yeah, so copper 2+ ions are going to be attracted to their opposite. And what's the opposite of positive? Tell me, everyone in the chat box, what is the opposite of positive? Remember that opposites attract. Opposites attract. So copper ions will be attracted if an object is negatively charged, which is why I attached the quarter to the negative part of the negative terminal of the battery so that the copper would coat the negatively charged object. Smiley faces if you guys remember that. That was from our lab that we did. Hopefully. Should have finished your lab. Unit 8 lab. Awesome. All right, Mr. Alch, Razi, Israel, Arrow, TJ on the board. Does this make sense? All right, so copper ions in solution are positively charged, so they are attracted to anything that's negative. So we attach a key or a quarter to a negative side of a battery, making it negatively charged. Those copper ions are going to hook up with the negatives and solidify into a solid plate of copper on top of our quarter or key. Red, sort of. Blue, yes. Yellow, not yet. 5 seconds. Let me know if that makes sense. Again, opposites attract. Positive ions attracted to a negative object. Love it. All right. What ions are released when acids are dissolved in water? Let's see here. Red, sodium, positive sodium. Blue, negative hydroxide. Yellow, negative chlorine. Or red, green, positive hydrogen. Remember, acids release what? Think about the definition of acids. What do they release in water? Think about hydrofluoric acid, hydrochloric acid. Think about acetic acid, right? What ions get released when dissolved in water? All right, it's actually H+ ions. Remember, this is the actual definition of an acid. So hydrofluoric acid or hydrochloric acid, they always release hydrogen, H+ ions, into solution. And those H+ ions are really good at ripping apart other molecules, which is why acids are good at breaking things down. Smiley faces if that makes sense. Okay, smiley faces if that makes sense. Yes, so acids all have that H in common, so the H is what they're releasing. All right, perfect. We got Mr. Altrazi, Israel, Arrow, Orlando on the board. Does this make sense? Let's take a look at our definition of an acid. Right, acids are compounds that contain hydrogen and when dissolved donate positive hydrogen cations. Right, so hydrochloric acid releases a positive hydrogen. Bases, on the other hand, do the opposite. Bases release hydroxide, negative hydroxides. So for example, sodium hydroxide releases the negative hydroxide. Red, sort of. Blue, not yet. Yellow, yes. Remember, these are the actual definitions of acids. Acids release H+, H+. and bases release OH negatives. Those are the actual definitions. Perfect. All right. Next one, strong acids or strong bases. Red dissociate completely in water, or blue do not dissociate completely in water. Think about strong acids, strong bases. Red, do they break apart completely in water, or blue, do they not break apart completely? 15 seconds. Strong acids, strong bases, do they dissociate completely or not? Red, yes. Blue, no. Uh-oh, Efren. This is a tricky one. They dissociate completely. They actually dissociate completely. All right, so remember, we talked about how acids will release H plus into solution. And if they're releasing H plus into solution, what do you guys think? Do you think that acids are going to be better at dissolving things or breaking things down if they release more or less H plus into solution? If those H pluses are the attackers, are they going to be more effective with more H plus or less H plus? Tell me in the chat box. Are they going to be more effective with more H plus or less at attacking other compounds? With more, right? If H plus are the attackers, all right, then if we have more of them, then the acid's going to be even better at breaking things down. So think about this. If we have more H plus, that means it's a stronger acid, which means in order to get all those H pluses, they need to completely break down in solution into as many H pluses as possible. Smiley faces if that makes sense. Smiley faces if that makes sense. We want as many H pluses as possible. Awesome. We got Mr. Alt, Razi, Israel, Efren, and Orlando on the board. Does this make sense? Take a look at this. Yes, Efren. All right, so a strong acid will dissociate completely into its separate parts. You can see no original HCl left over, whereas a weak one, the original acid, some of it stays there. Same thing with weak versus strong bases. Strong base completely dissociates, breaks down, whereas a weak base, some of the original molecule is still left over. Red, not yet. Blue, yes. Yellow, sort of. Let me know if that makes sense. Awesome. Thank you, Jasmine, Dorian, Tony, Israel, Damien, Misael. I see you in the private chats. Thank you. Love it. All right. In a neutralization reaction, an acid and a base react to make red base, blue salt, yellow water, or green acid. Think about neutralization. What were the neutral results of an acid and a base? What were the neutral results of an acid and a base? Think about when we mixed baking soda and vinegar, what is the final result? We talked about this in class. We debunked a myth, right? 5, 4, 3, 2, 1. All right, if you answered either salt or water, you actually got this correct because an acid and a base actually react to make both a salt and a water. Right? Remember we talked about how NaOH, which is a strong base, so sodium hydroxide, plus hydrochloric acid, HCl, which is a strong acid. When they react together, the Na and the Cl hook up, making salt, NaCl, which is a neutral salt, plus the OH and the H hook up to make what? Tell me in the chat box. H and OH make what? 2 H's, 1 O. What does that make? H and OH. Yes, it should make H2O. H2O, which is going to be neutral water. Neutral water. Again, it's all neutral, meaning that they are neither acidic nor basic in the end. Smiley faces if that makes sense. Smiley faces if that makes sense. All right. Looking good. Thank you. Thank you. All right. Mr. Altrazi, Israel, Efren, Orlando on the board. Michelle's the highest climber. Does this make sense? All right. So acids and base make salt and water. So for example, vinegar, baking soda react to make salt and water, which is neutral. They also create carbon dioxide gas in this case, which is why it bubbles. Red, not yet. Blue, sort of. Yellow, yes. Salt and water is always the result of an acid and base mixing together. Different kinds of salts, though, not all of which are edible. Right, and then water. 5 seconds. All right. Which of the following is not a characteristic of an acid? So which one is wrong? Red, found in bleach and soap. Blue, corrode active metals. Yellow, turn litmus paper red. Or green, taste sour. Which one is wrong? Which of the following is not a characteristic of acids? Bleach and soap, active metals, litmus paper red, sour. 10 seconds. Thank you, Andrea. Thank you, Tony. Thank you, Dorian and Israel. Dolly. 3, 2, 1. Yes, the fact that they are found in bleach and soap is false. Remember, bleach and soap are actually what? Bleach and soap are actually what? Tell me in the chat box if you didn't see the answer from Mr. Alch already. What are bleach and soap? Tell me in the chat box. Yes, they are actually basic. They are not acidic. They are basic. That's why they're slippery, and that's why they're bitter. Bases like bleach and soap are acidic. Are slippery and bitter, right? Whereas acids tend to be sour. Think about lemon juice or vinegar or lime juice or orange juice tend to be sour. They can corrode active metals, right? We talked about how they can break down things like aluminum and other active metals, right? The alkali and alkaline earth metals. And we talked about how they turn litmus paper red, right? Blue litmus paper, B for base. Red litmus paper is for acid. Smiley faces if that makes sense. Smiley faces if that makes sense. Thank you, Efren. Thank you, Caleb, Kiana, Noah, Orlando. Thank you, Israel. Thank you, Arrow. Love it. All right. Let's see here. Mr. Altrazi, Israel, Efren, Orlando on the board. Ashton is the highest climber. Does this make sense? Let's take a look at this. All right, so acids tend to taste sour. They're found in things like vinegar, orange juice, lemons. They will neutralize bases, cancel bases out, right? They turn litmus paper red. They increase hydrogen ions in solution. We talked about this. And they will corrode metals. All of these other ones are for bases, right? Bases neutralize acids, taste bitter, are found in cleaning things. They turn litmus paper blue, blue for B for base, slippery, and increase hydroxide. 5 seconds, red sort of, yellow, not yet, blue, yep. Good. All right. Next one. Acids have a low pH less than 7, red, middle pH equal to 7, blue, or high pH more than 7, yellow. Acids have what? Low pH red, middle pH blue, or high pH yellow. Think about the pH paper we used yesterday. Thank you, Misael. Thank you, Israel. Thank you, Tony. I know it's a tricky one. That's why we're reviewing it, Efren. All right, they actually have a low pH. All right, remember yesterday when we were using the pH paper, we saw that reds and oranges and yellows were all acids, like our vinegar and our lemon juice. So those things are all acidic, right? And those are all towards the lower end of the pH scale. Smiley faces, if that makes sense. All right, so we've got pH. All right, so close to 1. Close to a pH of 1 is acidic. What is the center one? What is 7? What does pH of a 7 mean? Tell me in the chat box. pH of 7 equals what? What's in the very center of our pH scale? Yes, Efren. Yeah, Tony, don't worry about it because we're not doing the attendance ticket right now. So just wait till the end. Yeah. So what is that called? Yes, it's neutral. Neutral like water. And then a pH close to 14 is what? pH close to 14 is what? Tell me in the chat box. If 1 is acidic, 7 is neutral, 14 should be basic. Yes, should be basic. Awesome. All right, everyone. We got Mr. Alch, Razi, Efren, Israel, Orlando on the board. Ashton, the highest climber. Does this make sense? All right, so low pH actually means we have high hydrogen concentration, which means it's an acid, so acid's lower pH. High pH means we have the opposite, low hydrogen concentration, so bases are actually on the upper side. Remember, they're opposites, right? Red, yep, yellow, blue, not yet, yellow, sort of. 10 seconds. Let's make sure that makes sense. Thank you. 3, 2, 1. Love it, looking good. All right, a solution that resists changes in pH is called a titration red, indicator blue, or buffer yellow. What is a solution that resists changes in pH? Keeps pH as close to the same as possible. 15 seconds. No, Efren. 10 seconds. Awesome, thank you all the private chat people. Yes, it's called a buffer. Remember, we talked about in class how a buffer between friends is someone who acts like a mediator and helps keep the situation calm, right? Helps people from going to extremes when you're buffering the relationship between two people that are fighting. In the same way, buffers in science do the same thing. They prevent extremes from happening. If you try to add acid, the buffer tries to keep it at the same pH. If you try to add base, the buffer tries to keep it at the same pH. Smiley faces if that makes sense. Oh, awesome, Efren. Yes, Ireland. All right, let's make sure that that makes sense. You got Mr. Altrazi, Efren, Israel, Orlando on the board. Does this make sense? Let's take a look at this. So buffers resist pH changes when an acid or base is added. Remember, they're made up of a weak acid and its opposite or conjugate weak base. And these weak acid and weak bases are able to react with any additional acid or base that's added in order to create more weak acid or more weak base and water, which keeps it close to the same pH. Red, yes. Blue, not yet. Yellow, sort of. Let me know if that makes sense. 4, 3, 2, 1. They resist changes. Awesome. All right. Let's take a look at our results here. Congratulations, Mr. Altrazi, Efren, Israel, and Orlando. I'm going to save these. I'm also going to save the people who were in the private chat, so give me a moment to do that. Looking good. All right, so I got Dolly and Dorian in the private chat, Misael, Tony, and Israel, Jasmine, Damien, and Andrea. You guys were all participating in the private chat, and you answered every question. Awesome. Saving that. Cool. All right, let's take a look. Sorry, I do see that I'm getting some chats here. Ethan, if you were in the game, it'll be in the report. So I'll just take a look at the report. Yeah, Dorian, you're good. I saved yours. Awesome. Cool. All right, everyone. Let me go ahead and here we go. We're going to send out the attendance ticket again, Mr. Alch, if we can send that out one last time with the password. Okay, there we go. And here is your last word. Thanks so much, everyone. I will see you all later. Last word is copper for today. Bye, everyone. Have a great day. If you need anything, it'll be in the recording, or you can always email us, but we do need to go to our next class. Bye. Thank you.